Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of identifying functions. This is standard 8.5G in the great state of Texas, and we are using item number 6 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a relation contains these 5 points: 1, 2, 2, 1, -1, 3, 0, 4, 1, and 5, -1. And which statement accurately describes this relation? Take a look at the pattern. So the relation does not represent y as a function of x. The relation does represent y as a function of x. Does not y as a function of x, and does represent y as a function of x. So before we do anything, let's just really narrow down on what that means, because everything is about whether it is or is not a function. Two options say it is a function, two options say it is not a function. So what actually is a function? You're not going to find enough context clues to define it here. So a function is a relationship in math when one input always leads to one output. So our input is always going to be our independent variable, and our output then is going to always be what we're solving for. It's going to be our dependent variable. And so we have already labeled that for quite a few years now. We know that our input, our independent variable, is going to be x. So we start with x, we multiply it, divide it, add to it, subtract from it, and we're always looking for our answer on the other side of the equation, which is going to be our dependent variable, which ends up as y. So 1x always leads to 1y. So that makes it a function. So let's line these up vertically. I always find that to be a little bit easier rather than reading across. So 2, -1. I've got 3, 0. I've got 4, 1. And I've got 5, -1. So you see the pattern there. Our x's are actually going in order there. And that's fine. 1, 2, 3, 4, 5. So this does look like a function. And so I'm going to put a check mark there. Take a look at our y's though. I've got 2 of these that both go to -1. And that's fine. You can have multiple x's going to the same y. What you cannot have though is when you've got 2 different x's in that same function that go to different y's. So each input goes to its own output, and if 2 goes to -1, if 5 goes to -1, that's fine, because what you don't have is 2 going to -1 and like 0, or 5 going to -1 and 6, or something like that. Each input goes to an output. So let's look at our answer choices here. F, the relation does not represent y as a function of x, because each value of x is associated with a single y value. Now, like I said, it's a little bit tricky, but you can have multiple y values that are the same as long as each x is different. So that's going to be incorrect. G, the relation represents y as a function of x because, so that's going to be yes, one value of y is associated with 2 x's. Now that's true. This -1 is associated with 2 x's, the 2 and the 5, but that's not what makes it a function. We just have to say that's okay. So that's not going to be it. H, the relation does not represent a function of x. No, it does, because each value of y is associated with 2 values of x. That's not even true. Only one of them is. And then J, the relation represents y as a function of x, because each value of x is associated with a single value of y. There you go. That is our answer. It's J.